This video is for lesson 30-2 about areas of triangles. Learning goals are to solve problems using areas of triangles and to work with triangles on the coordinate grid. In our last lesson, we wrote some formulas for area of a rectangle and parallelogram on our note pages. In this lesson, you're going to want to add this formula to your note page. This is for the area of a triangle. It's 1/2 times base times height. The reason that formula works is that any triangle can be shown to be half of a corresponding rectangle. For example, if I take this triangle and I draw a congruent triangle right above, notice how this is a rectangle. And this rectangle has a base and height. The area of the triangle is only half of the area of that rectangle, hence this math formula. So let's jump down to question 3 and try a couple examples where we're finding the area of a triangle using the formula. So area of a triangle is equal to 1/2 times base times height. This is 1/2 times 5 times 2. This answer is 5 square feet. Or question B, let's say we want to find the area of this triangle. We would use the formula area equals 1/2 times base times height. This is 1/2 times 2 times the height. But to complicate things, we don't have the height shown in this drawing. We can find it. Let's draw straight down from the top, touching the bottom right there. Then this distance across here is 1 foot. And we have a right triangle. The A is 1. The B is our height that we're trying to find, and the C is the 4. So we can go A squared plus B squared equals C squared, the Pythagorean theorem. 1 squared plus B squared equals 4 squared, and therefore B squared equals 15. 4 squared is 16, 1 squared is 1, 16 take away 1 is 15. So B is the square root of 15. So even though it wasn't given to us in the picture, we can find that the height of our triangle is the square root of 15. And that's what we fill in for the letter H in the formula. 1/2 times 2 times the square root of 15 is the square root of 15 square feet. For question C, notice that while we have the base, we don't know the height. So we need to do that same technique. Draw straight down to the middle of the bottom so that we can find that this much is 3, and then we'll be able to figure out the height. I'm going to pause the video for you to work on question C. You need to find the height, then you can find the area of the triangle. So let's use the Pythagorean theorem. We have A squared plus B squared equals C squared. 3 squared plus B squared equals 6 squared. So B squared equals 36 minus 9, which is 27. So B is the square root of 27. This letter B is our height of the triangle. Now we can use the formula for area. Area equals 1/2 times base times height, which is 1/2 times 6 times the square root of 27. This answer is 3 square root of 27 square feet. You certainly can take a calculator and find out what this answer is as a decimal. Let's jump ahead to the check your understanding questions. Find the area of the tabletop shown on the coordinate plane. Remember that the other day we were talking about a scenario where a company charges $8.50 per square foot for a tabletop. So to find how much to charge, we would need to be able to find the area of this pretty complicated tabletop. This is a composite figure made out of rectangles and triangles. We can use our formulas to find the area of each piece of the figure. Let's first find the area of the large rectangle on the bottom. It is 4 tall and it is 14 long. So 4 times 14 is 56 square units. Then we could find the area of this small rectangle located here. It's 2 wide and 5 tall. That's 10 square feet. For our triangle pieces, we'll use our formula for area of a triangle. Let's do this triangle here on the left first. 1/2 times the base. The base goes from -7 to 0, so that's 7 units, times the height. The height goes from 0 up to 5. So 1/2 times 7 times 5. That's 17.5 square feet. Now our other triangle. 1/2 times the base times the height. The base goes from 2 over to 7, which is 5 units. The height goes from 0 up to 5, which is 5 units. So 1/2 times 5 times 5. That is 12.5. Now that we know all the pieces, we add those up to get the total area, and then can multiply by $8.50 to find out how much to charge for that tabletop. Next, let's take a look at number 7. Here we have a triangle, and we want to find its area. We can tell that this side here is 20 centimeters long. What we don't know is the height of the triangle. We could call it h for height. Do you recognize this situation from earlier this year? We have a right triangle with an altitude drawn. The length of that altitude is the geometric mean of the pieces of the hypotenuse. That means that we can write 6 is to h as h is to 14. Using cross multiply, h squared equals 6 times 14. 6 times 14 is 84. So h is the square root of 84. We can use our area formula for a triangle. 1/2 times base times height. Fill in that the base is 20 centimeters, and fill in that the height is the square root of 84. With a calculator, we get the answer 91.6 square centimeters. Next, skip to number 10. The diagram shows a triangular shaped tabletop. Let's find the area so we can figure out how much to charge. Like the last problem, we're going to need to use geometry ideas from earlier this year. We know the base of the triangle is 7 feet, so we can go area equals 1/2 base times height, which equals 1/2 times 7 times the height. But we don't know the height of the triangle. We could first draw it in. It goes from point C down to segment AB, touching at a 90-degree box, and we could label that h for height. We can use trigonometry to find that answer. From the 49-degree angle, the letter h is the opposite side. The side with the 5 on it is the hypotenuse. We need to use the sine function. The sine of the angle equals opposite over hypotenuse. To solve for h, multiply by the 5. With a calculator, we can get the answer for h. 5 times the sine of 49 degrees is approximately 3.77. That's the number that we needed to know up here. 1/2 times 7 times 3.77 is 13.2 square feet. We wanted to find the area of a triangle, but we did not know all of the numbers that we needed to know. So we looked for ideas from earlier this year that would allow us to figure out those unknown measurements. In this problem, we used trigonometry. In the previous problem, we used an idea called geometric mean.